our goal is to prove that this is equal to this. It's not an equation if they tell us to prove it. We're just supposed to show that this is the same thing as this over here. To make that happen with a proof, we start with the left statement, the first statement, and we keep reworking it until it matches the right statement over here. Oops, sorry, this is cosecant squared. That's a big difference. If it's cosecant theta, then they're not equal to each other. Okay. So cosecant squared alpha minus 1 over cosine alpha. We're supposed to prove that equals this. So whenever you see a trig function being squared, you should be thinking about the trig identities. And one trig identity that we have is that cotangent squared, we could call it x, theta, whatever you want, cotangent squared of a variable plus 1 equals cosecant squared of a variable. In this case, our x is alpha. But this is a Pythagorean identity. You could search those. You could search trig Pythagorean identities online. You'll see the 3 big ones. This is the one I'm going to use because I can rework this one. If I just subtract 1 from both sides of this identity, it's still talking about a true statement. We did a balanced step, right? Cotangent squared of alpha, or x, or whatever variable you want to say, is equal to cosecant squared x minus 1. So I've reworked it so that I have something to substitute into the left side of the statement. I'm going to rewrite the whole top as cotangent squared alpha. That's all over cosine alpha. Okay, looks a little simpler. We're getting closer to this goal. If I'm ever stuck, I like to consider things in terms of sine and cosine. So if we do that, cotangent is the reciprocal of tangent, and then tangent is sine over cosine. So that means cotangent is just the flip. Cotangent is going to be cosine, and it's squared, right? Everything's being squared. So cosine squared over sine squared. That's another way of writing cotangent. And then that's what the top is. I've just rewritten it as this, but it's still being divided by cosine. Now I've got everything in terms of sine and cosine, but it's looking a little yucky. Instead of writing it like this, we can write it with a division symbol. That way we don't have fractions on top of fractions. Same thing, right? Fraction is saying one thing is being divided by another. So, and if we write it like that, then we could divide by flipping and multiplying. So this is cosine squared alpha over sine squared alpha times 1 over cosine alpha. And these cross simplify, right? So now you got cosine times 1 makes cosine. And we have sine squared in the denominator. Let's go back and check and see how close we are. We need a cotangent and a cosecant. So I've got my cotangent if I separate this a little bit, because cotangent we said near the beginning was that cotangent is cosine over sine. I've got that, but I still have another sine to deal with, right? I can't just pull out a sine and put it nowhere else. It's not equivalent. It's 1 over sine alpha. This is cotangent, and this is cosecant. So we're done the proof now. We have cotangent alpha times cosecant alpha. Okay, so we've done it. We took the left side, we kept rewriting it using what we know about trigonometry, and we eventually got it to match the right side. So the proof is complete.